Now, I'm sure all of you have wondered at one point or another, how big is our universe? Where is the edge of the universe? Can we ever reach the end of the universe? What could be at the edge of the universe? These are really intriguing questions. Unfortunately, even with the tremendous advancement of human technology, it is impossible to observe or find the edge of the universe. Why can't we go to or even see the edge of the universe? Let's find out the reasons behind this. In the beginning, there was nothing in this world. There was no time, space, or matter. Naturally, there were no galaxies or stars either. Then suddenly, a massive explosion occurred, originating from a single point, the Big Bang. With the Big Bang, everything in the universe began. Time started to flow, space was created, galaxies and stars emerged, and atoms and other forms of matter came into existence. The truly fascinating fact is that before the Big Bang, the universe was condensed into a size smaller than an electron, and it began expanding with the start of the Big Bang. The rate of the universe's expansion truly unimaginable. Just 1/1,000,000th of a second after the Big Bang, the universe's expansion speed was faster than the speed of light. You might think like this: what? The expansion rate is faster than the speed of light. The explosive force must have been tremendous. Or perhaps you thought, no. According to Einstein's theory of relativity, nothing can exist faster than light. So how can the universe expand faster than the speed of light? Is Einstein's theory of relativity wrong? Or is there something strange about the Big Bang theory? It seems ironic, doesn't it? However, the interesting fact is that both the idea of the universe expanding at a speed faster than light and the theory of relativity, stating that no material object can exceed the speed of light, are correct. This is because what is expanding in the universe is not any specific material, but space itself. Therefore, even if space itself expands faster than the speed of light, it does not contradict the theory of relativity. Isn't it fascinating? Let's explain this phenomenon with a very simple example. All right, let's say we have a balloon here. Let's pretend this balloon represents the space of the universe. Now, let's draw galaxies on this balloon and then inflate it. As the balloon expands, which means as the universe expands, the distance between galaxies gets farther and farther apart. At first glance, it may seem like the galaxies are moving, but in reality, it's the expanding space itself that's making the galaxies move apart and appear to be moving. Now back to the Big Bang story. When only a fraction of a second had passed since the Big Bang, the universe expanded by a tremendous scale, 10 to the power of 50, and the universe is still expanding now. This expansion rate is getting faster as time goes by. So, the universe is continually expanding and the expansion rate is getting faster. What will the universe look like in the future if this expansion continues? Well, if there are no events in the universe that can significantly slow down this expansion, in about 1500 years from now, the number of stars visible in the night sky will be much fewer than what we see today. According to research by scholars, 99.99% of the galaxies around the Milky Way will be beyond the observable range. In other words, stars will no longer be visible. Galaxies are moving away at such a fast speed, even faster than the speed of light in some cases, that the light from those galaxies will not reach Earth. This doesn't mean that galaxies will disappear, but the light emitted from them will not reach Earth. So, from the perspective of humans on Earth, it will look like as if the existence of other galaxies has effectively vanished. Currently, there are about 100 billion observable galaxies. However, after 150 billion years from now, this number will decrease to just a few thousand. As time goes on, we will only be able to observe 36 galaxies. All other galaxies and stars will appear to disappear completely. After a very long time, the night sky, once filled with twinkling stars and galaxies, will become pitch black. If there are still astronomers on Earth several billion years from now, they might think local clusters of galaxies do not move apart from each other. So the universe is not expanding. Our universe consists of 36 galaxies. The universe maintains a static state. This is what they would come to believe. Then why don't the 36 galaxies disappear? That's because the gravitational force between locally clustered galaxies is strong enough to overcome the expansion of the universe, preventing them from disappearing from our view. The cosmic space created by the Big Bang is expanding at a rate much faster than the speed of light. This expansion speed is accelerating over time. The greater the distance between galaxies, the faster they move apart. Keeping this fact in mind, let's say we now board a spaceship that can travel at 99.99, the speed of light, and go to the edge of the universe. However, we can never reach the edge of the universe. This is because the expansion of space is faster than the speed of light of the spaceship. As this is a kind of physical law, there is no way to ignore it. So we cannot observe the light approaching from the edge of the universe, and conversely, even if we travel at the speed of light, we can never ultimately reach the edge of the universe. Anyway, due to this physical constraint that space expands faster than light, the scientific community has created a spherical space based on Earth. This range is called the observable universe. Well, at this point, one might wonder, how big is the observable universe? To answer this question, scientists used the WMAP satellite to accurately capture the state of the universe 380,000 years after the Big Bang, and based on this, humanity has determined that the age of the universe is approximately 13.8 billion years. Now, having confirmed the state of the universe 380,000 years after the Big Bang and its age, would the radius of the observable universe be 13.8 billion years? It might seem intuitive, but we have overlooked one crucial fact. The light that is reaching Earth now is from 13.8 billion years ago. However, the universe has been expanding throughout its lifetime since its birth 13.8 billion years ago. The source of the light is said to have moved much further away, to a distance of 46.5 billion light-years since the beginning. Therefore, it has been concluded that the current size of the observable universe is a sphere with a radius of approximately 46.5 billion light-years centered around the Earth. Well, now for the last question. If the observable universe is determined based on Earth, what could be beyond the observable universe? Is it impossible for us to observe or visit that universe? Unfortunately, since humans cannot defy the laws of nature, even if the moment of the universe's end comes, we will never be able to reach the edge of the universe or know what lies there. Therefore, scientists can only speculate about what could be beyond the unobservable universe and how much farther it extends, since they can never know for sure. Some experts say if the observable universe were compared to the size of a single atom, the entire universe could be as large as the actual observable universe. Other experts may say, since the observable universe is the limit of human perception, it may not be the true edge of the universe. Yet another expert may say, Beyond the observable universe, the universe could extend infinitely. Well, there is no correct answer among these. Like a Marvel movie, there could be a sudden multiverse unfolding, or the universe might not be as big as we think, and we could quickly reach its end. However, the interesting fact is that since this is an area humans can never know for sure, it allows for many fascinating speculations. Or perhaps one day, advances in science and technology may allow us to discover where the edge of the universe lies. As we journey to the farthest reaches of the universe, venturing beyond the boundaries of our celestial dreamscape, what do you imagine awaits us in the mysterious expanse that lies beyond the cosmic horizon?